Welcome back to this third part of us creating a new game for the Crowded Party Game Collection. So in the last video we saw that we already were able to control our tower, but all the different towers were at the same position. So the first thing which we want to change is that. So we have to know some positions where the towers should be. To know that positions, I opened GIMP and drew or imported our pictures. And here in these pictures we can find the positions where we want to draw our tower. So I think we can put a tower here, 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 there, 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 and there, and maybe even there. So to store those positions we have to use some sort of data structure. I use an array list. It's that's an array of flexible size, and we use something called vector2f. It just stores two floating point values. It's out of the API of the Crowded Party Game Collection, and we call it positions. Or let's call it player underscore positions, capital P position. So I like that. New array list. Okay, it doesn't know it yet because we have to import it. Turn to F. So Control Shift O organizes our imports and adds the vector2f and the array list as well. Okay, so let's store those positions which we look up. To do that we use another function which we didn't use yet. I tried to use as many functions as possible in this example to give a good introduction. We use init. Init is called once when the whole game is initialized. So it's not called activate is called every time we start the game. Initialize is called once when we first load the game. So it's a good place to store the positions here because we only need those positions once and they won't change. We don't have to reset them. Okay, so player positions dot add new vector2f. So now let's look up a position. So I think maybe I'll zoom a little bit in to find the position here. I'll do a guess. I think this seems to be a good position. 313, 836. 313, 836. Okay, so this is our first position. To speed this whole thing up, I already prepared the other positions and took them out of GIMP. By the way, you saw them in the bottom left here. You can see where you're pointing. You can just guess them. That's what I did first. I already did mix them up because we will use one position after the next and we don't want our players to spawn directly between each other. Okay. So nearly done. This is the last one. So now we've got this array of player positions, and we could get the first position, which is available by calling get 0. This would be like, it would return one vector containing two floating point values. The first one is the x coordinate 313, and the second one would be 836. So what we want to do is every time we spawn a new player, we'll take the first position our player at this position, and then put the position which we took at the back, so that it will be reused after, I think, 10 positions, so that we never will go out of positions. So in the player, when we are created, we have to call, okay, let's make it easier. We make this static as well, public static. Then we can easily reference it by just calling game.playerPositions dot pop. Is there no pop? Then let's do it like this. Vector 2f position we have to import it. So now we'll call this dot set position dot x position dot y. Okay, we gave it two doubles instead of floats. That's one of the things which is ugly. I probably will change that, because it's called vector 2f. Originally those were floating point values. I did make them static, didn't I? I didn't save it, so that's why I didn't realize it. Okay, so now we would have set every player to the first position. That's not good. So what will we do? We call game.playerPositions remove the first and put it back at the start, player at the end, at position. So we'll take the first one, set our position, remove it, and put it back at the end. Okay, now we have to change this down here. We have to draw our tower where it is. There's this function called getX, and there's a function called getY, which returns the position of the current collision object. Good. Let's add another fancy thing. We want that every tower is in the color of the phone of the player. So what we can do is we call API.setColor phone getPhone. So this will set the drawing color of the whole thing to the color which is associated with our phone. GetPhone is called on our player, API player. API player always stores in the super event our phone reference. We can call it with getPhone. API set color. So let's say our phone color would be red. So everything afterwards will be red as well. And to make sure that not everything is red afterwards, we should reset our color to white afterwards. Or otherwise, we'll leave this function and we still would be drawing red in this case. Okay, so now let's try it. But first we'll go into the settings and make sure that debug mode is enabled, because we want to add some phones for trying this out. Okay, we run game. While it's starting, I'm doing my Chrome startup stuff. We'll open the debug mode as well. (108). Missiles. Start game. And here you see we can control our turret and we don't control the other two. Let's add some other players by pressing T, like teapot. It's maybe not in the best order, but we could spawn a lot of towers. We could spawn more than positions available, but at least it works for the 10 players which are recommended. We'll add just one other thing. Let's add the possibility of shooting as well. To shoot, we need a new object. We need a rocket. We create a new class called rocket. Rocket extends API collision object. We have to add the constructor. Everything's fine so far. So we add a tick function, tick control space, draw control space. So there are the two functions. We want to change the signature of the constructor. A rocket should know which player it is associated to. Otherwise, it wouldn't know who should get points if the rocket shot hit something. So let's just add a private. Okay, let's make it public. A public player. This player equals player. And we have to set the bounding box because we want to use our collision system. We use an axis aligned bounding box at our position, and let's make it 15 in width and 15 in height. So what is an axis aligned bounding box? An axis aligned bounding box is just aligned to its axis, so there is no rotation. We could use as well an oriented bounding box that has the same parameters, but there's rotation as well. So you probably wonder, why don't we use rotation stuff? We could, but I want to keep it simple. It wouldn't be that tough, but it will work like that. And you won't see the change of rotation. In our draw function, we want to draw an image. The image, we want to rotate the image, but because this really would look crapid. So graphics, missiles, rocket.png. We want to draw it at our position, so get x, get y, 0, and here we call get direction. I know there are a lot of fancy functions which I just seem to be inventing on the go, but sometimes you maybe just have to guess whether the function exists or not. I plan on publishing a better documented API later on. Okay, so another thing, leaving screen. this method will be called when you're leaving the screen. If you can't see the rocket anymore, we just want to delete it. Okay. So far so good. You probably wonder why is our rocket moving and when is it moving? We have to create a record and then set the velocities. So how do we do that? It's quite easy. There's an event called onButton event. There's no button yet. Maybe let's first create the button. Phone.addButton. This is the first. Stick 0 and button 1. Why? 0.5 is for X. It's 50% in width and 100% in height. For the displayed string, we just call it shoot. It's having some issues because we gave doubles by saying 0.5. We once have to cast to float. Now everything should be fine. Now we can react on clicking this button. So here in the onButton event, we have to return a boolean. This will tell the system whether other things which listen in the system to events of the button should be notified as well. If we return true, we use the event and nobody else should react. But to be honest, it doesn't really matter in this context. If button event is button pressed, so when you press the button and release it, those are two separate events. So this is like an on key down event, and we only want to react to one of those three events, and we want to create a rocket when a button is pressed. So rocket equals new rocket. We create it at our position, get X, get Y. We give this player as reference, and this dot level as reference. Let's make our rocket moving. Rocket.set velocities. This may be a little bit frightening to you, because we have to use fancy trigonometry or whatever it's called in English. But it's not that bad. So we use math.cosine, and in the system we always use decrease, but cosine needs radians. So we have to convert our decrease to radians, and then we use get phone dot get stick 0 for our first stick dot get direction. So we can copy most of this and use it for the y velocity as well. The thing which we have to change is we have to switch to the sinus, and we have to make it negative. So what does it mean? So direction of 0 points to the right, and if we take the cosine of 0, it will be 1. So we will be fully moving in x velocity, which is fine. And if we've got 90 degrees, we've got the cosine of 90 degrees is 0, so we are not moving in this direction. And for the sine, it's equally good. If we've got a direction of 0, the sine is 0 because we don't want to have y velocity, and if we've got 90 degrees, sine of 90 degrees is 1, but we want to move up, so we have to negate it, to make it negative. Okay, if you didn't understand that yet, it's not too bad. For this last parameter relative, we enter false. This means whether we want to add the values which we gave to the existing velocities, or whether we want to set them to the values we set. We have to cast them to float because of the strange definition of the API, which I will change. And let's just enter a carriage return to make it a little bit nicer. Now we'll multiply both of them with 5 so that our rocket will be a little bit faster. Okay, now we have to set the direction as well of our rocket, because set velocities doesn't do that. And we'll just use getPhone, getStick0, dot getDirection. Okay, cool. So let's look whether it really works. We start the game. We'll enter the server ID 108. Press on missiles. Start game. Here's our game. We can point into the direction, and there it is. Wow, very fancy. We can shoot rockets. Can we shoot rockets as well? Yeah. Nice. I like that. Looks great. I hope you like it as well. Okay, so far for this video tutorial. In the next video we'll add asteroids and points, and we'll just try to make it playable, finally, our game. Thanks for sticking by. Give feedback and I'll answer any question as fast as I can. And yeah, see you in the next video. Till then, bye.